authority against Copernicus. I'm not going to analyze the validity of the 18 mathematical and physical arguments here. Some of them, like the star sizes, were solid, or certainly would have seemed solid granted the knowledge of the time. Some of them were weak, even granted the knowledge of the time. What is clear is that Ingoli's challenge to Galileo, the essay that Galileo believed to have been influential in the action of the congregation and the index, was a challenge about matters of science. Okay? This is especially true since Ingoli suggests to Galileo that he ignore the 4 arguments about religion. Okay? Respond, says Ingoli, to whatever arguments you wish, but at least to the better ones among the physical and the mathematical arguments. So, what were those Inquisition and Congregation Index churchmen thinking when they rejected the system of Copernicus? Apparently, they were thinking about the same thing Buscaglia was likely thinking about when he was with the de Medicis, Tycho Brahe. How can you go wrong siding with the greatest astronomer of the age? And you don't even have to mess with the literal words of the Bible to do it. They probably thought that the decree of March 5th, 1616 was just a no-brainer. They did not stand with Galileo, and I think that you would not have stood with him either. You would have stood with this guy, Tycho. Okay. Now, let me take a minute for some questions, and I have a few closing remarks about that, sort of the applicability of this. But the thing I need to bring in is to mention at the end is that the apparent sizes of stars, the magnitudes, turn out to be an illusion. Okay? Stars, you go out and look at back, there. You go out and look at the sky, it looks like this. Okay? Bright stars look big. First magnitude stars look bigger. 6 magnitude stars look like little pinpoints. Okay? This is correct. And if you take an unbiased person who doesn't know anything that doesn't know better, who hasn't been taught otherwise, somebody who knows how to make measurements, especially like somebody who works in construction or something like that, knows how to do, they will walk out and you say, look up at that star. How many of those would take to fit across the moon? And they'll come up with that 10, 15, 20, something like that. They'll come up with the same values Brahe did. Because Brahe came up with the same values that like Ibn Sina came up with. Okay? Who came up with about the same values as Ptolemy came up with? Because that's what it looks like if you have good eyes. Okay? If you have bad eyes, they look like fuzzy balls. Okay? If you have good eyes, they look like little round dots. It turns out that those round dots are illusions. Okay? They are caused by a phenomenon involved in diffraction and seeing and a bunch of other complicated stuff that would not get worked out until at least the astronomers would not begin to figure out that the sizes of stars were not actual physical sizes until at least 50 years after all this goes down. That's the beginning. Okay? Not 100 years after that goes down do they actually start hammering it out and really believing that no, those where it starts to become accepted that those are not actual size stars, star sizes. But if you've ever heard of the Cassini division in Saturn's rings, Cassini is in the 1716 is arguing is measuring the size of Sirius as what it looks like as being its actual size. So that's even 100 years later. There's still a very prominent astronomer taking the sizes of stars as being what they appear as being a representation of their physical size. So that has to get worked out. They have to figure out that the star sizes are not real before Tycho's argument falls apart. Okay. Otherwise, you're stuck with, if you're a Copernican, you're stuck with this. Okay. So, like I said, I got a couple more things to comment on, but at this point, I'm going to take questions, and I'll see how time goes by. A few closing comments about sort of the applicability and importance of history of science. So,
thanks. That's
we're done.
like 8:30 after all the questions. We don't have a fixed time, but around 8:30 probably is
What time is it right?
about 8:05.
Okay, so I'll take a few questions. I got some closing stuff. Sure. If anybody's got it.
Yeah.
Okay. The I thing when it goes out gets bigger and bigger, and he can go out at 700,000. How far off, if he would have just believed himself, was he from the correct thing? See what, you understand what I'm
Okay,
saying?
all right, let's look at, well, basically what he's calculating, 7,000 times the furthest the sun is like 7,000 astronomical units, okay?
Let's just-
And the stars are at more like 150,000 astronomical units. So, I mean,
What I'm saying is that he said they're getting bigger, so it would have to be that much further, and he just wouldn't believe that.
yes, he would not believe, he did
But
not,
if you would have followed that train of thought, you might realize, you might have been able to calculate
calculate what?
the actual distance.
No, he is looking, you can't calculate the distance if you think that the star sizes you're seeing are physical bodies. Okay, they are,
Well, no, I believe that. I'm just saying that he, in his argument against the other, is saying that the star being that big and the other one not, he's mathematically taking it out further, but he did it as to discredit when you just fall in.
no, I mean, so the Copernicans believed him, right? Tycho, okay, think Tycho is NASA, all right? You know, Galileo is a guy with a telescope. Copernicus is some guy working in a cathedral. He's got a cross staff for measuring distances. Galileo has oodles of money, biggest observatory. He's the baddest ass in astronomy. Tycho is the biggest badass in astronomy. Okay. His measurements are as good as it gets. So you can't argue with his measurements, and his calculations are just basic geometry.
If he had a telescope.
No, he doesn't have a telescope. Okay, there's no telescope. So you can't argue with him. His logic is correct, right? I mean, if the Earth goes around the sun, there's got to be parallax in the stars. Has to be. You move, there has to be an effect. The only way there cannot be an effect is if the stars are really far away. If the stars are really far away, but they have a certain size that we see, 1/15 the size of the sun in the sky, but they have to be 7,000 times further away than the sun to have no parallax, because he can calculate the parallax. He's so good at his measurements, he knows he can get it if it's like less than half a minute of arc or something like that. You know, he knows he's got it. You can't argue with the geometry, you can't argue with measurements, you just have to accept it. Okay? So the Copernicans, this is something that's generally not well understood, is that lots of Copernicans looked at that and said, okay, I buy that. Okay, and you know what their argument was for why that was okay? It's because God is powerful and he can make big stars if he wants. That's the argument. And Tycho said, I don't believe that that's a good scientific argument. Is that, oh, God is powerful. So that's the solution to our problem. See, Tycho looked at this and he said, look, your problem is, to put this in more modern terms, Tycho viewed the faraway stars as an ad hoc solution to solve a problem with a theory. The theory says there should be parallax. There's no parallax. So the Copernicans, in Tycho's view, speaking as Tycho, the Copernicans just take them and stick them way out far away. So, we don't have parallax because they're far away. And then he goes and calculates that they're really big, and they say, okay, they're really big. God can make them big if they want. But he does not think that that is a good scientific argument. And he has a very persuasive case. Tycho is a very good scientist.
And the size of the stars would have been partially affected by the diffraction through the atmosphere. You can't get a very accurate size of an object that way.
Well, you can if you're Tycho.
Well,
You can. One of the things that's very difficult to understand is how much time a person would spend. Tycho knew about the atmosphere. He spent a bunch of time trying to triangulate the distance of Mars to test whether the Copernican theory. Tycho was open to the Copernican theory being right. He spent a bunch of time trying to triangulate the distance to Mars because in the Ptolemaic theory, Mars could not be closer to Mars always had to be further away from the sun. And in the Copernican theory, it would be closer. So if you could triangulate and prove that Mars came closer to the Earth than the sun, he proved that Ptolemy was wrong, Copernicus was right. Then he realizes he can't do it because of atmospheric effects. So he is, this is a guy who is getting a hoard of money to do astronomy and can hire all the best assistants. Johannes Kepler is an assistant hired by Tycho Brahe, as are quite a few other very prominent people from that time. And he's just really good. He knows about the atmosphere. He can measure down these pretty well. It's just that he's measuring something that's actually there, but it's not, any light that passes through an aperture forms what's called an airy disk. It forms a size. There's no thing in that, no true pinpoint in optics, okay, that is seen or detected with a camera or a telescope. So he can make those observations. He's just seeing something.
on the telescope.
He's before the telescope. He dies in 1601. Telescope is 1608.
Oh, Oh, okay.
Yeah.
I thought he was right.
No, he dies in 1601. The telescope doesn't help. The telescope confuses the heck out of everybody because they look through the telescope. That's a whole different story. This guy.
These were the earliest forms of the sextant. When was the sextant invented? All that was triangulation that even
Yeah.
U.S. Naval schools taught up to a few years ago.
And they're going back to teaching it. It's just on the news. I heard on the news yesterday because they're worried about the reliance on GPS and electronic warfare screwing up that system. So they're teaching people again how to do the celestial navigation to continue.
Parshwater is the only organization right now that teaches that. It's for free courses. But in the story is that you needed to know it just in case your GPS battery went dead.
Yeah.
Well, it's a lot easier to set GPS and doing about 52 equations.
Tycho has, I mean, his instruments are all sort of celestial measuring instruments, are in a sense like big glorified protractors of various sorts. There's one. Okay, so this is very stylized, but here's one, and it's measuring here from 0, 20, 30, 40, 60, 70, 80, 90 degrees. It uses these little diagonal lines back and forth, so as you slide an arm along it, you can get a better reading. So it's essentially all of his instruments are about measuring distances and sizes on the sky. But he doesn't have a telescope. But the telescope doesn't solve the star size problem, or else Cassini wouldn't be arguing about it in 1716. Yes?
How long did it take you to translate all that?
A long time. Well, wait a minute. Ingoli's letter is not. So this is the weird thing about this stuff, okay? This, you think that, well, and this is his famous story. Everybody ought to know this stuff, right? Okay? This is the first. You're not going to find a copy of that anywhere, okay? Where are you going to find it? From me. Okay. And you think to yourself, well, surely, this is like, well, no. It's part of what this all boiled down to whether there was a certain punctuation mark in this thing. Okay, this guy Finiciar, he says in a book, he says, there's a semicolon after this. He says basically this is two statements, foolish and absurd in philosophy, or scientifically untenable. One statement, contrary to the Bible and heretical in another. Okay. A lot of these translations say that it's foolish and absurd and heretical, all because it's contrary to the Bible. It's not. It's foolish and absurd. Science is bad because they believe Tycho, and contrary is second. You look through and found a dozen different sources that give it, and they all give different punctuation on this. And so the only way to get, I asked Finocchiaro, I said, okay, you sure about this? Because I can't find anything else. He's like, yeah, I'm sure about this. Do you have a copy of this? No, I don't. And so it's just, I was like, okay, I'm going to try just asking the Vatican if they'll send me one. Yeah, that'll be $10. And then that was it. But you would think that would, that'd be known. It's not. Ingoli's letter was translated, was never translated until last year. Another thing is that I'm working on is a translation of this thing by this guy Loker. I just found out yesterday that it's going to get published. And Galileo makes great fun of it. But it turns out his arguments are really good. And he's got the star size argument in there. He doesn't say that Venus doesn't circle the sun. He's got Jupiter and its moons, and he shows how to calculate where the eclipses of the moons are and how to use this to triangulate the distance from the sun to Jupiter. And he suggests a couple of research projects, all this stuff. Really smart guy. But Galileo makes him look like an idiot, and and that's pretty much what we've all followed. And it's just amazing. Ingoli's thing did not get published until like the 19th century, but it's never been translated. That's weird. And the reason you can do all this stuff is because it's all been posted on the internet in the last 20 years. So, before you'd have to go to some library in Europe, and they'd have to let you into the special vaults and all this other stuff. And now most of the libraries just have stuff, they have all their collections digitized. There's oodles of stuff just on Google Books. You go to Google Books, type in a specialized search. Say you want to limit your search to prior to 1600, and you'll come up with a whole bunch of books that are published in the 14 and 1500s, full copies. They look like crud. You can read them.
Something else